Hello, welcome to live.withcode.uk. This is the last in a mini-series of 5 episodes where we've been looking at a program that will read some data in from a text file. It will analyze that, it will display it as a text table, and then this final episode is where we can visualize that data as a pie chart. So we're going to use Turtle graphics for it. It's not the best way to do this. There are modules in Python that will do this much better. But this is aimed at GCSE Computer Science students who want some extra practice for the Paper 2 Edexcel online on-screen Python exam, where you have to be able to use the Turtle graphics module. So where we left off last time was we'd read the data in from a file, but we hadn't started anything to do with Turtle graphics yet. So anything to do with Turtle graphics needs an import at the top. So we'll import the Turtle module. And we're going to create a Turtle global variable. So we'll go inside the Turtle module, create a Turtle object, and we're going to call it T. That gives us a canvas to draw with. So let's think about what happens when we do draw a pie chart. We are going to need to draw a coloured arc around here, and then we'll go from the end of that arc to the middle of the circle, and then from that middle of the circle back to where we were at the beginning. So let's see if we can work out how to do each part of that. Let's find our subprogram that we made in the first episode called draw pie chart. We already know the total number of pies. We've added that up using a different subprogram. So we can work out the angle that we need to go round in the pie by saying the total number of pies, that's going to be divided by 360. That gives us the number of angles per pie. So if we can say for each pie in pie data, remember we've got a two-dimensional data structure that stores all of these here. For now, let's just remind ourselves what that data looks like. Let's see. Here we go. So we've got the name. We'll use that later when we display it. But this is what we're interested in. We want to convert that into a number of degrees. So let's see. Let's say angle equals pi. That gives us the list, the one-dimensional data structure. And if we want to get this number of pies, that will be index 1 because it's the second item in that list. And we start counting from 0. So that's the total number of pies. Let's multiply that by the total number of pies that we've got and divide it by 360. And let's see what that is. Oops, angle. That doesn't look very good, does it? Times 360 divided by the total. I've got my maths the wrong way around. There we go, that looks more promising. So hopefully these numbers added together should give us 360. So how do we draw an arc of that many degrees? Well, the Turtle module has a circle method, a circle procedure, and you can say how big the circle is going to be. So that's going to be the first one, the second one, and then the third one for leek and potato. But it actually accepts two different arguments. We can have the size of the circle, and yeah, we'll keep it to 100 maybe. But you can also specify the number of degrees. So if we put an angle there, then you won't see where it stops, but it does go all the way around, which is quite helpful. Next, we need some different colors here. So let's make a global variable. In fact, this isn't going to change. Let's make a constant. Colors. It's going to be a list containing all the different colors we want in our pie chart. We're only going to need yellow. So we're only going to need 3 of them because we've only got 3 pies. But it's conceivable that you might have more pies later. So there we go, something like that. And then we should get a new color. So how can we do this? Colour is, well, now we need a number to keep track of things. So I'm going to change the way that we iterate through here. Let's say for I in range, the length of p pi data, and then pi is equal to p pi data I. There we go. So it should be the same thing so far now, but we could also use I to get colours. Here we go. So we've got the colour, but we're not doing anything with the colour yet. Let's pop this here and set the colour. Now the built-in procedure to set the colour is built in, so it uses the American spelling, but I'm British, so the local variable that I've used is the British spelling. So we're getting there. We've drawn the hard bit, the slice of the pie. All we need to do now is go from here to the middle of the circle. So how do we do that? Well, we could work out the middle of the circle because it's going to be 0 for the x-coordinates and then halfway to the top. So this parameter that we've got here is the size of the pie. But is it a radius or is it a diameter? I'm not sure. Let's see. Yeah, there we go. Now, this does not look good. It doesn't carry on in the right place. So what we want to do is move along like we've done, go to the middle, and then go back to our starting point. And that means that we're going to need to keep track of where we were to begin with. So before we draw this, we should say pos equals t dot position. And then can we do t dot go to pos the x coordinate and pos the y coordinate? Will that work? Yeah, good. So we've got a slice, but it doesn't work all that well. But once we've got there, maybe we can draw that again to move around. Nope. Let's t dot, we need to rotate. Which direction do we need to rotate? It looks like it's rotated to the left, so we need to rotate it to the right to go back again. We know how much because we've already rotated by that much. Ooh, there we go. Yeah, that looks promising. So all we need to do now is fill in those shapes in those colours, and we should be good. So before we start drawing, we can say t.begin draw. I can never remember whether we have an underscore. No, we don't. Turtle module is a bit inconsistent here. And then t.end fill. Is it begin draw or begin fill? No, sorry, it does have an underscore. End fill and begin fill. There we go. So we've filled that in. We can draw the shape. We can fill in the shape. Get ready for the next piece. Excellent. Not great. Because it doesn't actually fill in the right place. So maybe we want to do the end fill before we move on to the next space. How about that? That's better, I think. Yep, that looks better to me. Great. Okay, so we've got the shapes. Now we just need the key, the legend underneath. So let's put a comment in here. Draw each slice, and I'll put another loop in underneath. Draw the label. Okay, let's think what we want. We want a coloured square down here and some text underneath. So for I in range, let's do the same as we did before, so we can get a colour. The length of our data structure that stores all of our data. T.go to, where are we going to go to? Let's go to the left a little bit, so it's going to be a minus number. I don't know, minus 50. And then how far down? I don't really know. Let's say 20 pixels multiplied by however much we've got. sorry, which one we're on so far. I'm going to speed this up so that we don't have to wait each time. So t dot speed 0 to go as fast as we possibly can. It's better. So once we've gone to the right place, in fact, we want to lift the pen up before we go to the right place and then put the pen down and repeat 4 times. So I can't use I again because I'm already using I in a loop. But I'm going to draw a square, which means I want to repeat this 4 times. Let's say for j in range 4, just anything to repeat 4 times. T dot forwards, I don't know, 10 pixels. T dot right by 90 degrees. So it looks like it's not far down enough. So can we have minus 50? Let's have all of that plus 100. Is that in the wrong place? No, maybe it needs to be minus 100. Yeah, that looks about right to me. Now we just need to be in the right colour. Let's comment this. Draw a box. What colour do we want? T dot colour. Colours I. There we go. And then let's fill them in. T dot begin fill and T dot end fill. That doesn't look good. No, we want to start filling in before the loop. Set the colour even before that, and then after the loop is finished, then we fill it in. Okay, good. So then I guess we want to lift the pen up, move forwards by maybe 100. Is that going to work? Nope, not. That's too much. Maybe 20, and then T dot right. Can you do that? I don't know. I can't remember how to put text in here. But this is going to be the pi data. This time the first number. So it looks like it's always steak and ale pie, which is not what we want. Yes, because we want to use I to just get the one that we want, and then the 0 to get just the name of it. Let's try that. Okay, better, but I'd like the name of the pie to be in black, so we can always see it. T dot color black. Oh, blue. Here we go. And I don't like the fact that the text is always too high. Maybe if we just go left instead, that looks okay. All I'm going to do is at the very end, T dot hide. Can we hide the turtle? No. Is it hide turtle? I can't remember. But I think it's okay. All right. So there's a bit of maths that you won't need to worry about here. Don't worry if you find it difficult to do the geometry aspect of this. That you won't be expected to do that in the exam. But I hope this gives an indication. This mini-series gives you an indication of how to go from the description of a bigger problem to break it down into smaller chunks, to read data in from a file, to store that file in a 2-dimensional data structure, to display that using string formatting, and we've also done some turtle graphics to be able to visualize it. So I hope that's helped, and we'll move on to a new mini-series next time.